This is POME, or palm oil mill effluent, the wastewater generated from the entire processing of fresh fruit bunches, or FFB, in a palm oil mill, which is discharged during the process. As is widely known, palm oil is extracted from fresh fruit bunches, or FFB, that are harvested and then collected from oil palm plantations. Harvesters cut the fresh fruit bunches from the palm trees, collect the loose fruits, and transport them to the harvest collection point. The harvested FFB are arranged, counted, and recorded before being loaded onto a fruit transport truck. Upon arrival at the mill, the FFB are first received at the weighbridge station to determine their total weight. They are then moved to the loading ramp station for sorting and placed onto the loading platform. The FFB are placed into steel cages, each capable of holding up to 2.5 tons of FFB. These loaded cages are then moved into the sterilization process at the sterilizer station. The sterilizer used is a horizontal type that applies high-pressure steam to boil the FFB for 60 to 90 minutes. This process allows the fruit to ripen and detach from the bunch, making oil extraction easier. After sterilization, the steam temperature drops and condenses into water, which is discharged through the drainage system into the blowdown chamber and subsequently into the sludge fat pit tank. The condensate from the sterilization process has specific characteristics. It remains hot, emits steam, and contains impurities such as oil and sludge. It also has a distinctive odor caused by the thermal reaction of heated organic materials. Back in the processing line, the boiled FFB cages from the sterilizer station are transported to the tripler or thresher machine, where the fruits are separated from the bunches. At this station, the fruits drop onto a conveyor and are carried into a rotating drum. The drum's rotation generates centrifugal force and impact, causing the fruits to detach from the bunches. This process produces two output: empty fruit bunches, or EFB, and loose fruits. The fruits are transferred and distributed via a vertical conveyor to digester tanks, where they are mashed to more easily separate the fruit flesh, or mesocarp, from the nut. The mesocarp is then sent to a screw press, where it is pressed to extract crude palm oil. The crude oil is sent to a vibrating screen, where it is filtered through fine mesh and mechanical vibration to remove coarse fibers, small shell fragments, and other solid impurities. Next, the crude oil undergoes purification through a sand trap tank, followed by a clarifier tank at the clarification station. At this stage, the oil is further separated from water, sludge, sand, and other residual materials. The resulting purified oil with reduced moisture content is now referred to as crude palm oil, or CPO, the primary product of the FFB processing. The CPO is then stored in a dedicated storage tank. Returning to the process at the clarification station, along with producing CPO, the process also generates liquid waste containing solids, sludge, and wastewater. The water originates from the steam used during processing to maintain high temperatures, typically around 80 to 90 degrees Celsius, to ensure the oil remains fluid and flows smoothly through the pipeline system. At the clarification station, one of the key processing units is the decanter, also known as a tricanter. It processes the sludge from the clarifier or settling tank, which still contains a mixture of oil, water, and fine solids. The sludge is fed into the tricanter, where it is separated into 3 components using rapid centrifugal force approximately 3,000 RPM. These 3 distinct phases are effectively separated and sent out through different outlets. The heaviest outer layer is solid, the middle layer is wastewater, the innermost and lightest layer is oil. Each phase is routed to separate outlets for further processing. The wastewater from the decanter still contains low concentrations of oil. It flows through pipes and ditches into an open tank known as the sludge fat pit. The wastewater from the sludge fat pit is pumped directly into the fat pit, marking the initial stage of the POME handling system. This wastewater retains some residual oil, grease, free fatty acids or FFA, suspended solids, dissolved organic matter, and remains in a heated state. In the fat pit, the temperature of the wastewater gradually decreases to 40 to 60 degrees Celsius. The system consists of a series of open tanks designed based on a slow flow principle, which facilitates the separation of oil from water and solids. Due to its lower density and higher viscosity, the oil rises to the surface, while the solids settle at the bottom. In the final tank, the floating oil and grease are manually skimmed off and returned for mill processing at the clarification station. The water and settled solids are discharged through drainage channels to the final station, Palm Oil Mill Effluent, or POME. POME consists of several ponds, each serving a specific function: cooling pond, anaerobic pond, facultative pond, aerobic pond, and polishing pond. In the first pond, which serves as a cooling pond, the oil appears as free oil, visible on the surface, and emulsified oil, which is finely dispersed in water and solids. The color tends to be dark due to the high organic content and elevated levels of free fatty acids, or FFA, typically ranging from 10% to 40%, or even higher. Due to the mill system, particularly the use of a horizontal sterilizer, the wastewater entering the effluent still contains a maximum of 1.3% oil, based on wastewater samples. Since the volume of POME is approximately 58% of the total FFB processed, the potential residual oil in the POME would be a maximum of 0.76% of the total FFB processed. The residual oil refers to oil lost during the previous stages of mill processing, commonly known as oil loss. To collect the floating oil from the first pond, a pit trap is set up. As the oil accumulates, it is pumped into storage tank. Once the tank is full, the oil is transferred to tanker trucks through pipelines for transportation.